All right, let's look at the homework 3.11, problem number 9. All right, so we have a telephone line between two poles 40 meters apart, and this can be modeled by hyperbolic cosine function. We got that. All right, so part A, find the slope of this curve where it meets the right-hand pole, so which is at x equals 7. All right, so let's find the derivative first. We need to find y prime is equal to, all right, 21 is just a constant multiple, so we just put that there here. All right, derivative of hyperbolic cosine is hyperbolic sine, so I'm going to put the hyperbolic sine there. And then you have x over 21, and then multiply by derivative of x over 21 is 1 over 21. And the derivative of negative 16 is 0, so I'm not going to even write that. Then we can clean it up. You can see that it's 21 on top and then 21 on the bottom, cancel out. So you're left with hyperbolic sine of x over 21, right? So if you want to find the slope, so slope m is going to be, so we look at the derivative and then plug in x at that point is 7, so we're going to plug in 7 there. So this is going to be a hyperbolic sine of plugging 7 here, 7 over 12, 7 over 21, it's same thing as 1/3, right? So we have that. All right, so we need to borrow technology a little bit here. So I'm going to open up GeoGebra here. And then we need to compute the hyperbolic sine of 1/3. So we have a hyperbolic sine of 1/3. Right, so it came out to be 0.3395. So let's type it in. So we have 0.3395. All right, let's check the answer. All right, I came back and looks like we got the part A correctly. All right, so let's move on to part B. We want to find the angle theta in degrees. So here we have theta there between the line and the pole. So let's try to find that theta. All right. All right, so let's try to draw a triangle there. So involving theta, right? So you have a theta. So I probably want to draw it like this first. All right, and here this is theta. Right, so since the slope is rise over run, right? So a rise in this case, so we can think of this guy as a rise. Oh, actually here, rise is going to be hyperbolic sine of 1/3, and then over run would be 1. So you can think of this triangle, this side, the rise is going to be hyperbolic sine of 1/3. And then this is going to be 1, so it's going to be 1. All right. So looks like so this is going to be the opposite of the angle. This is adjacent of the angle. So we can probably use tangent. We can do cotangent if you want. I'm going to use tangent because I like tangent better. All right, so tangent of theta is going to be equal to opposite over adjacent. And in this case, the opposite from the angle is 1. And adjacent to the angle is hyperbolic sine of 1/3. Right? So if you want to find the theta, so we can just simply apply our arctangent. So theta is going to be arctangent of whatever this guy is, 1 over hyperbolic sine of 1/3. So this is just the answer from part A, reciprocal. All right, so I'm going to bring up GeoGebra here. All right, so what we need to compute is, since we already know what the hyperbolic sine of 1/3 is, which is actually stored in A. So all we have to do is I have to do arctangent. So arctangent in GeoGebra is A tan, right? So you have an arctangent of 1 over. So this value is already stored in A, so I'm going to put A there, right? So it looks like we have a 71.24. What's the precision they want? We want to 2 decimal places, right? So it's a 71.25, okay? So let's type it in. Right, we have 71.25 degrees. All right, let's check the answer. All right, I came back and looks like we got the part B correctly as well. All right, that's it. I hope that this was clear.